Okay, very good. Thank you. I'm going to be showing you today how you can calculate population from a raster. Most essentially, how you can make use of the tool in ArcGIS, which is called Zonal Statistics as table, to be able to calculate a raster file, which falls within a particular shapefile. In this context, we have this particular area in Nigeria called Calabar. And this is the shapefile. As you can see, if you look at the attributes, you see it contains numerous names of the areas. So we can as well close this. Let's probably label it so we can be able to understand. So you see, it's a local government area, as we call it in Nigeria. And what we want to do is that we want to know the population of each of these local government area. We have the Nigerian population grid, which comes in raster. It's been gotten from the data.humdata.com, and the grid population data set comes in raster file format. Remember that we have vector and raster file format. So in this case now, we want to, firstly, what we need to do is that we're going to clip the areas that falls within this particular zone. That's one of the most important things. So do not forget also that the grid is in raster and it has its own property. We can check the property here to have more clarification. So if you click on source, you can check the raster information. Looking at raster information, you can see it contains 14,413. At the same time, it's trying to tell us that it's in 90 meter, meaning that the population proportion of each of the cell, that is, each cell occupies a particular number of population. So first thing we're going to do is to clip. So we need to clip to the extent of Calabar, which is our study area that we're working on. So very, very easy. We only need to just go to the geoprocessing tool here to search. So I have it here open already, but in your own case, you can search for geoprocessing tool. So when you have it here as a tab, then you search for clip raster. So it comes down here. So just click it. Then under clip raster, it brings out, it goes straight to it because we searched, so we don't have to. So click on clip raster. The first thing it's going to ask you is the input to raster. That is our raster file. In this context, our raster file is the LG population. And then it's going to ask also the output extent. So the output extent is our polygon, which is the Calabar. So we select Calabar. So you can see it shows the extent of the polygon. So very essentially also, we select use input feature for clipping geometry, so that it can only cover the shapefile line area of this particular study area. So we select this and make it active. Yes, another important thing is to select the location that you want it to be stored and the name. So in this context, don't forget that we want to extract the population raster for Calabar, right? We want to clip it from the large Nigeria raster. So I can just name it Cal_pop and _raster. So it's going to save on our database, which we have created earlier. Then you click on run. It will take a very brief minute to load, and upon loading, it's going to appear on the table of contents section. So to be able to understand the changes, I'm going to minimize the major Nigerian population raster. So you can see now here that we have already clipped area. So now in this case, we want to calculate the population in each of this particular place. Don't forget that each of the cell represents 100 populants. That is each of the cell. And if you look at this very well, you zoom in, you can see that we have so many cells, right? As you can see, so we will need to be able to sum how many cells we have in this particular area, which will enable us to understand the total population. Yeah, so here comes to one of the most essential tools in ArcGIS Pro, or in your own case, even if you use ArcGIS Map, it's also available there too. So we have done with this clip raster that we have this already. So I can just click here and go back, and then I close this and search for Zonal Statistics by table. Don't forget Zonal Statistics as table specifically. So one of the important things that we need here is we need to input the raster. So in this context, we need we need to input the feature that we want to zone. That is the shapefile that we would like to zone. So which is the Calabar study area. So you come here and choose Calabar, very essential. So it's going to ask me, what is the zoning feed? Do not forget to understand the zoning feed. We can come here, then come to the Calabar shapefile. You open it, and then you can look at it here. You see that we have names, right? So we want to zone it by names. We want to know the total summation of cells that we have in each of these LGs. Do not forget that the LG is the name, right? So we close it, and then we'll come down here, zone feed, and select name. So we input the value of the value raster, right? Which is our population raster for Calabar. So in this section, talking about the statistics type, that is because we are telling the computer that we need a statistics, right? So statistics contain a lot of, we have the mean, we have the median, we have the range. Just like if we go back to our elementary statistics that tell us more about measurement of central tendency and measurement of central measurement of central tendency precisely. So we have minimum, maximum, and so we can afford to tell the computer to give us a calculation of all the mean of the cells that we have here, or the maximum, or the minimum, or the range, which is maximum minus the minimum in this regard. So, but for this case, we can just tell the computer, but for this case, what really matters to us is the sum, actually. But for the concept of this learning, I will just allow the default to flow so that we can have the full calculation. So the same way, the output will come as a table, do not forget, and we have to be able to give it a name. So let's give it a name, and let's just call it Zonal underscore Cal. And then we'll just click on run. So it also takes a few seconds to load, so not too much. You just have to be a bit patient to see the output. So like I said earlier, it comes out as a table. Don't forget the name Zonal Statistics as table. So you see we have the standalone table here. You can double click on it, or you can right click and click on open. Then it will pop up. And what you can see here, you can see the names of the LG, and it's telling us the number of cells. That is C. We have 291. And the calculation based on the meter of each cells, or the population it represents. You can see here we have the area, we have the minimum, we have the maximum, we have the range. And then what is very essential to us is the summation. So you can see that is the summation of the population in this particular region is this. As you can see, it is 166,513. So if you convert this point here to this, it will give us 4. So now that we have this in table, what is the most important that we have to do is to do what we call table join. Right, we're going to do what we call table join. So we want to join this table here to the major shapefile, which is Calabar here. So how do we do table join? We come here and right click on it, and you come down here to join and relate. The same thing is applicable to when you're using the hack map, the hack map, which is the same as ArcGIS Pro actually. So we'll come here and do hard join. So the first thing it's going to ask you is what's the layer name? Yes, we have Calabar, and then input join by name, right? And then join table. That is, the layer name is the target that we want, and then and then the input join is the name, and then the join table is the table that we have here. That is the results from here, right? So then you can click on run. So now when we open the attribute table, in this context, you can see the attribute table that it has joined to, it has joined the Excel table to the major shapefile. So if you look at this here, you see we have the sum, that is the total cell here, give us the summation of the population that we have in each of the LGA. Do not forget that, as I stated earlier, that we make use of the grid population, which comes in raster. We decide to look for a way to sum it so that we can understand the population that reside in each of the LGA. Don't forget also that you can then as well now use this to visualize the population. However, you can also decide to visualize this summation to be able to understand the population in each of the LGAs. So we just come here and you go straight to symbology, then we symbolize by the sum. Or this is one of the best methods, or probably you can just go to appearance, then you click on symbology, which gives you several drop down. Then what we can do here is that we can use the unique value, right? Unique value, and then we'll come to the feed name in this regard, not the ID. Here we need the sum, right? Which is the population. We have the sum, and then this will come here. Then, so you see now we're able to visualize the population of each of the LG. But you can see that this only shows several type of color, right? It becomes so difficult to really understand which part of the LG have the highest population. So it's always very good to use what we call graduated colors. So we select this, it shows the range of the population from the low to the high. So we come here and choose the feed, and then we choose sum, which is the summation of population in each. So as you can see now here, that Calabar municipality, that is this place, have the highest population. So you see that we're able to make use of the grids to understand the population of each of the LGA. So in this context too, which is well labeled, you can see that it's another way to understand the population of each of the LGAs. Thank you very much.